Hello friends, welcome to VK lectures. In this lecture, from canonical ensemble, we are discussing a small part called quantum oscillator, where we will be discussing about the partition function of quantum oscillator. We will also deal with the average energy and the entropy. Also, we will be discussing about the specific heat capacity for quantum oscillator. Starting with the quantum oscillator, here the energy of the quantum oscillator in quantum mechanics, we have studied that the energy of the oscillator, harmonic oscillator, this is regarding linear harmonic oscillator. So energy of the nth state is given by n plus half h cross omega, where omega is the frequency. Now we also know by the canonical ensemble theory, the partition function z is equal to sum over s e to the power minus beta es. Es represent the energy of the state. Yes. Now when coming to the quantum oscillator has the states starting from 0 to infinity. So it has value 0, 1, 2, 3, etc. So number of states for 0 represent the ground state, for 1 is first excited, 2 is second excited state for a linear harmonic oscillator. Then the partition function for z for you can write the linear harmonic oscillator partition function is equal to sum from s, so we can write starting from n equal to 0 to infinity e to the power minus beta, and the energy is n plus half h cross omega, so n plus half h cross omega. So this is the linear harmonic oscillator partition function. Now just starting from n equal to 0, we have the energy levels. So let us write down E naught, that is the energy of the ground state, is equal to half h cross omega. Then E1, E naught, E1 is equal to 3 by 2 h cross omega. E2 is equal to 5 by 2 h cross omega. So it goes on. So replacing this summation by the terms such as so the first term, when n equal to 0, you have e to the power minus beta, n is 0, so h cross omega by 2, plus we have e to the power minus beta, n is 1, so 3 by 2, so 3h cross omega by 2 plus e to the power minus beta 5h cross omega by 2, and it goes on. So this is the partition function z. Now what we can do is take the first term and e to the power minus beta h cross omega by 2, so that's our first term here, plus so we will take half h cross omega out, and then once again start with sum over n equal to 0 to infinity e to the power minus beta n h cross omega. So we have taken half h cross omega by 2 as the common energy. So every term will have half h cross omega. So if you take half h cross omega out, it will be h cross omega here, 3h cross omega, 5h cross omega. So this gives us with the term that is before moving forward, let us understand about sum over n equal to 0 to infinity x to the power n is equal to x to the power 0, which is 1, plus x to the power 1 plus x to the power 2, etc. So this is from this is an sum of GP. So this forms geometric progression. So S infinity, the sum of the infinite terms, is given by the first term A divided by 1 minus R, where A is the first term and R is the ratio, that is called a common ratio. So looking into this idea, we can write this Z is equal to e to the power minus beta h cross omega by 2, and the second term is an infinite term, sum of infinite terms, which is equal to, so here the first term is starting from n equal to 0, so first term will be equal to 1. So if you put n equal to 0 here, e to the power beta, so n equal to 0, so first term is 1, so 1 divided by 1 minus the common ratio R. What is the common ratio here? So the first term is e to the power minus beta h cross omega by 2, and the second term is e to the power minus beta 3h cross omega by 2. So common ratio is e to the power beta h cross omega. So when you multiply these two quantities, this one and this one, you get the third. So e to the power beta h cross omega becomes the common ratio. So e to the power minus beta h cross omega. So this becomes the partition function. So partition function Z for the linear harmonic oscillator is equal to e to the power minus beta h cross omega by 2 divided by 1 minus e to the power minus beta h cross omega. Here we have a missing term, minus beta. So we have the partition function Z for the linear harmonic oscillator given by Z is equal to e to the power minus beta h cross omega by 2 divided by 1 minus e to the power minus beta h cross omega. So A divided by 1 minus R, sum of n terms. Okay, Now what we can do is we can divide the numerator and the denominator by e to the power minus beta h cross omega by 2. So what we arrive at is, so first the numerator becomes 1 and in the denominator we have e to the power minus beta h cross omega by 2. So dividing means it will become e to the power plus beta h cross omega by 2, and on the second term we have e to the power plus e to the power minus beta h cross omega by 2. So this is the term dividing by e to the power minus beta h cross omega, or what you can do is multiplying by e to the power beta h cross omega by 2. This makes a bit more easier. The first term plus and minus becomes e to the power 0, that is 1. Now e to the power x minus e to the power minus x is equal to, or this divided by 2 is sine hyperbolic x. Now we have here 2 sine hyperbolic x. This is this sine hyperbolic x, and with bringing this to the partition function z, we have z is equal to 1 divided by so e to the power x minus e to the power minus x. So it becomes 2 sine hyperbolic x. What is x? Beta h cross omega by 2. So beta h cross omega by 2. So this is the partition function in terms of sine hyperbolic function. So there are two partition function for linear harmonic oscillator. One is this one, e to the power minus beta h cross omega by 2, 1 minus e to the power minus beta h cross omega, or z is equal to 1 by 2 sine hyperbolic beta h cross omega by 2. Now finding the average energy of the linear harmonic oscillator. So average energy is given by U. The formula is minus dou by dou beta log z. So minus dou by dou beta log z. So we have z here. So now let us take this particular z for doing this problem. So that's equal to minus dou by dou beta e to the power minus beta h cross omega by 2 divided by 1 minus e to the power minus beta h cross omega. Here there is another term, log z, log of this particular quantity. Now we can say that log of a by b is equal to log a minus log b. So this can be written as minus dou by dou beta. The first term is log of e to the power minus beta h cross omega by 2, then minus of minus dou by dou beta of log 1 minus e to the power minus beta h cross omega. So here the first term gives us 1 by minus, so divided by e to the power minus beta h cross omega by 2, and its derivative will be equal to e to the power minus beta h cross omega by 2 into minus h cross omega by 2. So minus h cross omega by 2. So this, then we have plus, this is 1 minus e to the power minus beta h cross omega, then the derivative of the what is inside the bracket, that's equal to minus e to the power minus beta h cross omega into minus h cross omega. So this gives us how these terms get cancelled, so that becomes h cross omega by 2 plus, here we have the another term, that is you can take h cross omega out, h cross omega into e to the power minus beta h cross omega by 1 minus e to the power minus beta h cross omega. So this is the average energy U for linear harmonic oscillator. Now here we have seen the Z partition function for the linear harmonic oscillator can be written in this form, that is 1 by e to the power plus beta h cross omega by 2 minus e to the power minus beta h cross omega by 2. Now considering the U, that is the average energy, equal to minus dou by dou beta log Z. Earlier we have taken the Z as this one. Now let us try to find the Z, that is the average energy using this value. So let us see what we are going to get. So log Z, so this becomes minus plus dou by dou beta of log of Z inverse. So log of Z inverse is minus log Z, so minus and minus plus becomes plus. So this is equal to dou by dou beta of log Z inverse. What is Z? Z is this, so log of e to the power beta h cross omega by 2 minus e to the power minus beta h cross omega by 2. So this is the thing. Now continuing this, we have so dou by dou beta of log, so log x derivative 1 by x, so that is equal to the entire term divided by e to the power beta h cross omega by 2 minus e to the power minus beta h cross omega by 2 into its derivative, that is e to the power beta h cross omega by 2 into h cross omega by 2, then minus again we have here its derivative, that is e to the power minus beta h cross omega by 2 into minus beta h, sorry, we know based on beta h cross omega by 2. So what we have here, so let's write down that one. Here h cross omega by 2 can be taken out, So h cross omega by 2 in the numerator being taken out. This becomes e to the power beta h cross omega by 2. Minus of minus, it becomes plus. So plus e to the power minus beta h cross omega by 2. That's accounts for the numerator, and in the denominator we have e to the power beta h cross omega by 2 minus e to the power minus beta h cross omega by 2. Now we have seen e to the power x plus e to the power minus x equal to 2 cos hyperbolic x, and e to the power x minus e to the power minus x equal to 2 sine hyperbolic x. Now incorporating this into the equation, we have h cross omega by 2 times, this is 2 cos hyperbolic beta h cross omega by 2, beta h cross omega by 2 divided by, in the numerator we have 2 sine hyperbolic beta h cross omega by 2. This gives us h cross omega by 2, 2 to get cancelled, and what is remaining is cos hyperbolic x by sine hyperbolic x, which is nothing but cot hyperbolic beta h cross omega by 2. So this is the average energy for a linear harmonic oscillator in terms of cot or hyperbolic function. Coming to the Helmholtz free energy. Free energy, we have F as given by minus kBt log z, and z is equal to e to the power minus beta h cross omega by 2 divided by 1 minus e to the power minus beta h cross omega. So that's z. So F will be equal to minus kBt log e to the power minus beta h cross omega by 2 divided by 1 minus e to the power minus beta h cross omega. Right, now we have the entropy. Entropy, here we are using a different formula, that is entropy is equal to kb beta into u minus f. There is no differentiation or integration here, just the application of just apply u and f here, you get the entropy S. So S is equal to kb beta u minus f. So u is equal to, you can write u as h cross omega by 2 plus h cross omega into e to the power minus beta h cross omega divided by 1 minus e to the power minus beta h cross omega. So this is u here, and probably we will get to know this f. Yeah, so f is here we have, so S is equal to kb beta into u as h cross omega by 2 plus h cross omega into e to the power minus beta h cross omega divided by 1 minus e to the power minus beta h cross omega minus f, so that minus of minus become plus kbt log again we have the same terms, similar terms, minus beta h cross omega by 2 divided by 1 minus e to the power minus beta h cross omega. So this is the entropy. Now we need to calculate the specific heat capacity. Specific heat capacity at constant volume, that is CV, which is given by dou U by dou T, or dou by dou T can be written as minus 1 by kBT squared dou by dou beta of U. So we have U written in terms of h cross omega by 2 plus h cross omega into e to the power minus beta h cross omega divided by 1 minus e to the power minus beta h cross omega. You can also use u equal to h cross omega by 2 into cot hyperbolic beta h cross omega by 2. This one as well as for this. This looks very simple here. Let us do this one and let us see what is the specific heat capacity. So CV equal to dou, let's keep minus 1 by kBT. Okay, let us write down that minus 1 by kBT square dou by dou beta of U, so h cross omega by 2 plus h cross omega into e to the power minus beta h cross omega divided by 1 minus e to the power minus beta h cross omega. So that's it. Let's do the differentiation, dou by dou beta of h cross omega beta. So dou by dou beta of this h cross omega can be taken out because beta it is independent of beta, so e to the power minus beta h cross omega by 1 minus e to the power minus beta h cross omega. This is like a differentiation of u by v, that is u by v differentiation is v into derivative of u minus u into derivative of v divided by the denominator v squared. So that's equal to u, that is v is 1 minus e to the power minus beta h cross omega, that is the term 1, into derivative of u, that is e to the power minus beta h cross omega into h cross omega with a minus sign, so minus of u which is e to the power minus beta h cross omega into v dash, that is the denominator, minus e to the power minus beta h cross omega beta h cross omega into into the derivative of this minus beta h cross omega, that is minus h cross omega. Now the whole term divided by we have the denominator squared, that is 1 minus e to the power minus beta h cross omega whole squared. So we have we can take h cross omega out, and here we have another h cross omega, so with another again minus sign, so h cross square omega square by kb t squared into what is remaining is this is e to the power minus beta h cross omega divided by the denominator, that is 1 minus e to the power minus beta h cross omega whole squared. So this is the specific